Hi everyone and welcome back to the channel. In this video, I'm going to be diving into the contactless ignition system. We'll cover the device itself, how it operates, and some of the most common faults you might encounter. I'll also be showing you some similar systems and comparing their key features. So if you're working on car repairs or just curious about how modern ignition systems work, stick around, you won't want to miss this. Hey everyone and welcome back to the channel. Today, we're diving deep into the world of car ignition systems, specifically the contactless kind. We'll be looking at why these systems fail, how to diagnose problems, and even how to tackle some repairs yourself. First up, let's talk about wear and tear. Contactless ignition systems, while incredibly advanced, aren't immune to the effects of time and use. Natural wear involves the gradual degradation of components due to heat, vibration, and the constant electrical stresses they endure. Think of it like the mileage on your car. The more you drive, the more wear and tear accumulates. Premature wear, on the other hand, is often caused by things like poor maintenance, using incorrect parts, or even electrical surges. We'll explore specific examples of both, so you can identify potential issues early on. Next, we'll unpack the inner workings of a microprocessor ignition system. These systems are far more sophisticated than their older counterparts, using microprocessors to precisely control the timing and intensity of the spark. We'll break down the different components, explaining how they interact to create that crucial spark that ignites the fuel-air mixture in your engine. Understanding this process is key to effective troubleshooting. Now, let's address a common issue many car owners face: a malfunctioning windshield washer pump. While seemingly unrelated to the ignition system, this highlights the interconnectedness of various car systems. A faulty pump might point to a broader electrical problem that could also affect your ignition system. We'll explore this connection and how to diagnose the root cause. Many of you have asked about upgrading classic car ignition systems. So, let's talk about the possibilities of adapting modern microprocessor ignition systems (MPFSZ) to classic vehicles. We'll discuss the challenges and potential benefits and explore what modifications might be necessary for a successful conversion. This is a more advanced topic, but we'll make it as clear and accessible as possible. For those of you with classic cars, we'll also cover the intricacies of adding microprocessor control to your existing ignition system. This is a significant undertaking, requiring a good understanding of both electrical systems and your specific vehicle. We'll discuss the steps involved and the potential pitfalls to avoid. Now, let's get our hands dirty. We'll walk through troubleshooting and repairing common ignition system issues. We'll cover everything from simple checks you can perform at home to more involved repairs. Remember, safety first. Always disconnect the battery before working on any electrical components. Finally, we'll tackle the often overlooked ignition distributor. Even in modern vehicles, some still utilize distributors. We'll cover the common problems associated with these components and how to diagnose and fix them. We'll look at things like worn points, faulty condensers, and mechanical issues that can disrupt the ignition timing. This section will be particularly helpful for those working on older vehicles. Hey everyone, and welcome back to the channel. Today, we're diving deep into the world of car ignition systems. Specifically, we're going to tackle those pesky malfunctions and how to diagnose them. Let's start by looking at the signs that tell you your ignition system needs some attention. First off, you might notice a rough idle. Your engine might be sputtering, hesitating, or even misfiring. This is a classic sign that something's not right with the ignition system. It could be a weak spark, a faulty component, or even something as simple as a bad connection. Another telltale sign is a complete failure to start. If you turn the key and nothing happens, the ignition system is a prime suspect. Don't forget about that check engine light. If it's illuminated, it's often a good indicator that there's a problem somewhere in the ignition circuit. And finally, reduced fuel economy. If your car is suddenly guzzling more gas than usual, a malfunctioning ignition system could be the culprit. A weak spark can lead to incomplete combustion, wasting fuel and reducing your mileage. Now, let's talk about some common ignition system malfunctions. One of the most frequent issues is a faulty ignition coil. These coils are responsible for boosting the voltage to create the spark that ignites the air-fuel mixture. A failing coil can produce a weak or intermittent spark, leading to misfires and poor performance. Another common problem is a damaged distributor cap or rotor. These components are crucial for directing the high-voltage spark to the correct spark plug. Wear, cracks, or carbon buildup can disrupt the spark delivery, causing misfires and starting problems. Worn-out spark plugs are another frequent offender. Over time, the electrodes on spark plugs erode, leading to a weaker spark and ultimately, poor combustion. And finally, we have the ignition control module, or ICM. This electronic component controls the timing and duration of the spark. A faulty ICM can lead to a variety of problems, from misfires to complete engine failure. Remember, these are just some of the most common problems. There are many other potential issues. Next up, let's discuss the often overlooked importance of the better trampola. Now, I know what you're thinking, what's a trampola? Well, in simpler terms, it's a crucial component that ensures the precise timing of the spark. A malfunctioning trampola can lead to significant performance issues and even damage to your engine. Think of it as the conductor of your ignition system's orchestra. If it's out of sync, the whole system suffers. Regular maintenance and inspection of the trampola are vital for optimal engine performance. Identifying a cylinder that's not firing is crucial for effective diagnosis. You can use a compression test to check the pressure in each cylinder. Low compression in a specific cylinder often points to a problem with that cylinder's ignition system. You can also use a spark tester to check if each spark plug is receiving a strong and consistent spark. A weak or absent spark indicates a problem in the ignition circuit leading to that particular cylinder. Visual inspection of the spark plugs themselves can also reveal clues. Look for signs of fouling, wear, or damage. Now, let's delve into some possible ignition system malfunctions in more detail. We've already touched on some of the common culprits, but let's explore them further. A faulty crankshaft position sensor, CKP sensor, can prevent the engine from starting or cause erratic running. This sensor tells the engine control module, ECM, the position of the crankshaft, which is essential for precise spark timing. A failing camshaft position sensor, CMP sensor, can also cause similar problems. This sensor monitors the camshaft's position, which is crucial for fuel injection timing and valve operation. These sensors work in tandem with the ignition system, so a malfunction in either can significantly impact engine performance. Let's move on to the main causes of auxiliary equipment failures. Often overlooked, these seemingly minor components can cause major headaches. Worn or damaged wiring can lead to intermittent or complete loss of spark. Corrosion on connectors can also disrupt the electrical flow, leading to misfires or starting problems. A failing ignition switch can prevent the ignition system from receiving power altogether. And finally, a low battery voltage can also affect the ignition system's performance, leading to weak sparks and starting difficulties. Regular checks of these components are essential for preventing unexpected breakdowns. Now, let's talk about how the whole system works. The ignition system's primary function is to generate a high-voltage spark at the precise moment to ignite the air-fuel mixture in the engine cylinders. This process begins with the ignition switch, which sends power to the ignition control module, ICM. The ICM, in turn, controls the ignition coil, which boosts the voltage to create the high-voltage spark. The spark is then distributed to the spark plugs via the distributor cap and rotor in older systems or directly to each spark plug in modern systems. The timing of this spark is crucial for optimal engine performance and efficiency. Finally, let's briefly touch on adjusting the MPSZ, motor position sensor. The MPSZ is a critical component that provides information about the engine's rotational speed and position. Precise adjustment of the MPSZ is essential for accurate spark timing. Improper adjustment can lead to misfires, poor fuel economy, and even engine damage. This adjustment is usually done using specialized tools and requires a good understanding of engine mechanics. It's best left to experienced professionals unless you have the necessary knowledge and equipment.